In July 2015, a spacecraft called New Horizons traveled past a distant world and sent back images that changed how scientists understood the outer solar system. The small frozen body, known as Pluto, appeared in those images not as a simple ice ball, but as a complex world with mountains, plains, and geology that no one predicted. You are now approaching that same world yourself, descending through the darkness toward a surface that humans have only seen from millions of kilometers away during that single flyby. The spacecraft has brought you here, and soon you will walk on ground where sunlight takes over 5 hours to arrive from the sun. The view from your orbital approach shows Pluto growing larger against the absolute blackness of space, and subtle variations begin to appear across the surface below. What first looked like a small frozen sphere now reveals bright regions, darker plains, and long stretches of terrain that extend toward a sharply curved horizon. Sunlight reaches this distant world with only a fraction of its familiar brightness, and broad shadows stretch across features that remained completely unknown until recent decades. Every minute of descent brings new details into view, and the landscape slowly changes from an astronomical object into a place that feels real and physical. You are listening to the Drowsy Astronaut, and tonight we are taking a slow journey to Pluto, the small and distant world at the edge of our solar system. Over the next few hours, we will explore its frozen surface, moving across its mountains, plains, and strange landscapes as if we were standing there ourselves, looking out across a world that is almost impossible to reach. One of my favorite parts of these journeys is hearing from listeners around the world. So if you would like, let me know where you are listening from and what time it is in the comments below. And if these quiet journeys through space help you relax or fall asleep, you can support the channel by leaving a like or subscribing for more explorations. Slowly and thoroughly, we are approaching tonight's destination, Pluto, a small frozen world drifting in the darkness at the very edge of our solar system. From this distance, details begin to resolve on the surface below, and the first feature that becomes clear is a large pale shape that stands out against the darker terrain surrounding it. The shape resembles a heart, and scientists who first saw it in the New Horizons images named the region Tombor Regio, after Clyde Tombor, who discovered Pluto in 1930. The heart shape dominates the hemisphere facing you as you descend, and it consists of two distinct sections with different colors and textures even from this altitude. The western lobe appears brighter and smoother, while the eastern lobe shows more texture and slightly different coloring. And together, they create the impression of a geological heart across the surface. As the descent continues, other features become visible around the heart-shaped region, including darker areas that stretch across other parts of the surface, and highlands that show different textures. Pluto measures about 2,380 kilometers across, making it smaller than Earth's moon, and this size means the horizon curves more sharply than it would on larger worlds. The entire world would fit inside the borders of Russia, with room to spare. Yet the features you can see suggest complexity that rivals much larger planets. From this altitude, the scale becomes clearer, and what appeared as small markings from farther away now reveal themselves as mountain ranges, plains, and regions that will take days to cross on foot. The colors visible from orbit range from bright whites and tans to dark reddish browns and grays, and these variations indicate different materials covering different regions of the surface. Water ice dominates much of the terrain, but other ices also appear, including frozen nitrogen, methane, and carbon monoxide, each with different properties and behaviors at the temperatures found here. The temperature on Pluto's surface remains around 40 Kelvin, which converts to roughly minus 233 degrees Celsius, or minus 387 degrees Fahrenheit. At these temperatures, substances that exist as gases on Earth become solid ices harder than rock, and the landscape below consists of materials that would seem familiar in name, but alien in form. Looking toward the horizon, you can see where sunlight illuminates the surface and where darkness takes over on the far side. And this boundary between day and night is called the terminator. The terminator cuts across the surface in a sharp line because Pluto has almost no atmosphere to scatter light and create gradual twilight zones like Earth experiences. Sunlight that reaches the surface has traveled roughly 5.9 billion kilometers from the Sun, taking over 5 hours to complete the journey, and it arrives much dimmed by distance. The Sun from Pluto appears as the brightest star in the sky, but it provides only about 1,000th the light that reaches Earth, and the landscape below exists in permanent twilight by Earth standards. Another object appears in the sky above the horizon, and this is Charon, Pluto's largest moon and constant companion in a mutual orbital dance. Charon measures 1,212 kilometers across, making it about half the diameter of Pluto itself. And this size ratio makes the Pluto-Charon system more like a double planet than a planet and moon. The two bodies orbit a common point in space between them, and they are tidally locked, meaning the same hemisphere of Pluto always faces Charon, and the same hemisphere of Charon always faces Pluto. From the hemisphere of Pluto you are descending toward, Charon hangs in the sky and never rises or sets, remaining in the same position day after day and year after year. From the opposite hemisphere, Charon never becomes visible at all, remaining forever below the horizon. Charon appears grey and somewhat less colourful than Pluto, and even from this distance you can see it has its own surface features, including a dark polar region and lighter equatorial areas. The distance between Pluto and Charon measures only about 19,500 kilometers. Close enough that surface features on Charon are visible without magnification from Pluto's surface. The moon subtends a large angle in the sky, appearing roughly 8 times larger than Earth's moon appears from Earth, and its presence adds a second geological world to the sky above this already complex landscape. The two bodies complete one orbit around their common center every 6.4 Earth days, and this same period defines the rotation of both worlds, locking them in perpetual mutual observation. The descent path takes you over the bright western lobe of the heart-shaped region, and this area is called Sputnik Planitia, named after the first artificial satellite launched by humanity. The plain stretches approximately 1,000 kilometers across, and from this altitude, it appears remarkably smooth compared to the rugged terrain surrounding it. The smoothness suggests a young surface, and the brightness indicates high reflectivity, which means the material covering this plane is relatively fresh and uncontaminated by darker substances. As you descend lower, subtle patterns begin to appear on the plane's surface, features that were invisible from greater altitude, but now start to resolve into cellular shapes. The terrain surrounding Sputnik Planitia shows a completely different character, with mountains rising at the edges and rough highlands extending beyond. And the contrast between the smooth plain and the rugged surroundings becomes more pronounced the lower you descend. To the west of the plain, peaks rise several kilometers above the surrounding terrain, their slopes appearing rough and broken even from this height. These mountains consist of water ice, which at Pluto's temperatures behaves like granite or basalt does on Earth, hard and capable of supporting steep slopes and sharp peaks. The discovery of mountains this tall on a world as small as Pluto surprised scientists who expected such a small body to have a simple, inactive surface. Beyond the mountains, darker terrain extends toward the horizon, and this region shows a reddish-brown coloration distinct from the brighter ices of Sputnik Planitia and the grey water ice of the highlands. The darkness comes from complex organic molecules called tholins, which form when ultraviolet light and cosmic radiation interact with methane and nitrogen ices on the surface. These molecules accumulate over millions and billions of years, creating some of the darkest and oldest terrain visible on Pluto. The contrast between young, bright plains and ancient dark highlands demonstrates that Pluto has a complex geological history, despite its small size and distant location. The descent continues toward the smooth expanse of Sputnik Planitia, and the altitude decreases to the point where individual features within the plane become visible, instead of appearing as a uniform bright surface. The cellular patterns mentioned earlier now resolve clearly, showing polygonal shapes that fit together like irregular tiles across the plane's surface. Each polygon measures somewhere between 10 and 40 kilometers across, and the boundaries between cells appear slightly darker and lower than the centers, creating a subtle network of trenches across the otherwise flat plane. These patterns indicate active geology, processes happening on the surface right now, rather than ancient features frozen in time. Choosing a landing site requires identifying a smooth area without obstacles, and the central region of one of the larger polygons appears suitable for touchdown. The surface within the polygon looks flat and uniform, without rocks or ridges that might interfere with landing equipment or walking afterward. The cellular pattern suggests convection in the nitrogen ice below, with warmer ice rising in the centers and cooler ice sinking at the edges. But the motion happens so slowly that the surface remains stable enough for landing. You adjust the descent trajectory toward this chosen spot, and the final approach begins toward the bright ice plain that dominates the western lobe of Tombor Regio. The altitude continues to decrease, and details that were invisible moments ago now appear on the surface below, including subtle color variations within the bright ice and small-scale texture that adds complexity to what seemed perfectly smooth from higher up. The horizon curves sharply away in all directions, a reminder of Pluto's small size and the fact that you could see much farther if there were any tall features to view from. The sky above remains perfectly black, and stars are visible everywhere except where Charon hangs, suspended above the landscape, and where the sun glows as an intense point of light. The Terminator lies far to the east, and full daylight illuminates the landing site, though the quality of light remains dim and cold by Earth standards. The final meters of descent show the ice surface approaching, and you can now see that the nitrogen ice has a very fine texture, smooth but not perfectly mirror-like, with a matte appearance similar to freshly fallen snow on Earth. The color appears slightly off-white, with a faint tan or cream tint, and this coloration comes from small amounts of other materials mixed with the nitrogen or deposited on top of it. The landing site sits near the center of a polygon that extends many kilometers in every direction, and the boundary trenches marking the cell's edges are barely visible on the horizon as slightly darker lines. Everything is ready for touchdown, and the surface of Pluto waits just below. The landing gear makes contact with the nitrogen ice plane, and the descent engines shut down, leaving you on the surface of a world nearly 6 billion kilometers from Earth. The silence is absolute because the thin atmosphere cannot carry sound, and no wind exists to create noise or movement in the landscape around you. Pluto's gravity pulls at only about 6% the strength of Earth's gravity, meaning everything feels extraordinarily light, and the effort required to move or lift equipment becomes almost trivial. You have arrived on Sputnik Planitia, standing on nitrogen ice that accumulated in a vast basin and now convexed slowly beneath your feet. The exploration of Pluto begins here, and the smooth ice plain extends in every direction, waiting to be examined and understood up close. The first step off the landing platform demonstrates the low gravity immediately, and your foot sinks only slightly into the nitrogen ice before meeting firm resistance. The ice feels solid underfoot, hard and stable, with none of the crunch or give that snow or even water ice might have on Earth. At 40 Kelvin, nitrogen ice behaves more like frozen rock than the soft frozen gases you might imagine, and it can support your weight without deformation or compression. The texture against your boot sole feels smooth but not slippery, and walking will require adjusting to the low gravity more than adapting to unusual traction. Taking several steps away from the lander confirms that movement in 6% gravity requires a completely different technique than walking on Earth or even on Earth's moon. Each step wants to launch you upward if you push too hard, and you quickly learn to move with gentle motions that keep you in contact with the ground. The horizon sits much closer than on Earth, only about 3 kilometers away in any direction due to Pluto's small radius, and this proximity creates an enclosed feeling despite the vast open plain. The ground extends flat and featureless around the landing site, broken only by the subtle cellular patterns that mark the boundaries of the convection cell you are standing within. The brightness of the ice reflects the dim sunlight efficiently, and the plain glows with a soft luminosity that makes the surface easy to see despite the sun's weakness at this distance. Looking down at the ice near your feet shows the fine texture more clearly, a surface that appears somewhat granular at close range, with tiny variations in height and density. The coloration remains off-white, with that slight tan tint, and there are no visible rocks, boulders, or debris of any kind interrupting the nitrogen ice expanse. The plain here in Sputnik Planitia is composed almost entirely of volatile ices that froze out of the atmosphere or accumulated from sublimation and deposition cycles over millions of years. Walking in a straight line toward the north allows you to cover ground quickly once you adapt to the low gravity, and each step carries you forward several meters with minimal effort. The temperature reading from your suit shows the expected -233 Celsius, cold enough to freeze every gas in Earth's atmosphere, except perhaps helium and hydrogen. Nitrogen ice dominates the surface composition here, but instruments also detect carbon monoxide ice and methane ice mixed in, each contributing to the complex behavior of this plane. The mixture of these ices affects how the surface responds to temperature changes and how the convection cells below organize themselves into the polygonal patterns visible from orbit. After walking several hundred meters, you stop and look back toward the lander, which appears small and isolated against the vast white plain, the only vertical feature visible on the flat horizon. Turning in a complete circle shows the same bright ice extending in every direction, with the polygon boundaries barely visible as subtle darker lines crossing the plane at intervals of tens of kilometers. Charon hangs in the sky exactly where it was when you landed, appearing as a grey sphere with visible dark and light regions on its surface. The moon has not moved and will not move from this position in the sky, because Pluto's rotation keeps the same hemisphere facing Charon always. The stars fill the black sky from horizon to horizon, and the Milky Way crosses overhead as a dense band of light that would be spectacular by Earth standards, but here forms part of the normal background. Without atmospheric scattering, the stars do not twinkle, each remaining a steady point of light that allows precise identification of constellations familiar from Earth. The Sun sits near the constellation Taurus from this vantage point, though its position in Earth's sky would be equally different when seen from this distant location. The quality of light falling on the ice plane resembles deep twilight on Earth, enough to see clearly, but without the brightness or warmth associated with full daylight closer to the Sun. Looking more carefully at the ice near your current position reveals subtle color variations, with some areas appearing slightly more tan or cream-colored, while others look cleaner and whiter. These variations probably come from different concentrations of contaminants, or different mixtures of the volatile ices that make up the plane. And they add visual interest to what could otherwise be a monotonous white surface. Small-scale features appear as well, including tiny ridges a few centimeters high and shallow depressions that might be miniature sublimation pits where ice turned directly from solid to gas and escaped into the atmosphere. The surface has texture and detail when examined closely, even though it appears perfectly smooth from altitude. Walking continues toward the nearest polygon boundary, which lies several kilometers away and will take some time to reach, even with the long strides possible in low gravity. The boundary appears from here as a slightly darker line crossing the plane, and getting closer should reveal what these boundaries look like up close, and what materials accumulate in the trenches between cells. The polygons form because of convection in the nitrogen ice layer, which may extend several kilometers deep into Pluto's crust in this basin. Warmer ice rises in the centers of cells due to internal heat, and cooler ice sinks at the edges, creating a slow circulation pattern that organizes itself into these roughly hexagonal shapes. The timescale for this convection is extraordinary by human standards, with one complete cycle taking somewhere around 500,000 years to complete. The ice at the center of the cell you are walking across is slowly rising and spreading outward toward the boundaries, where it cools and eventually sinks back down to begin the cycle again. This means the surface beneath your feet is moving, flowing, renewing itself constantly over geological time. And the smooth appearance of Sputnik Planitia results from this constant recycling. No impact craters mark the plain because any crater that forms gets erased by the convection within a few million years, leaving the surface perpetually young and fresh. Continuing the walk toward the boundary allows time to consider what this plain represents in the larger context of Pluto's surface and the solar system. Sputnik Planitia sits in a large basin that may have formed from an ancient impact, though other formation mechanisms remain possible. The basin, filled with volatile ices over time, and the combination of depth and composition allowed the convection pattern to establish itself. The plain measures roughly 1,000 kilometers across and several kilometers deep in places, containing an enormous amount of nitrogen ice that makes up a significant fraction of all the volatile ices on Pluto's surface. This concentration in one location may have affected Pluto's entire orientation, possibly causing the world to rotate into a position where the basin faces toward Charon. The walk continues, and distance markers show you have covered nearly 2 kilometers from the landing site, with the polygon boundary still ahead, but growing nearer. The effort required remains minimal, and the low gravity makes walking long distances easy as long as you maintain rhythm and avoid pushing off too hard with each step. The plain around you looks the same in all directions. Bright ice reflecting sunlight under a black sky, with no landmarks except the distant boundary line ahead, and the lander now far behind. The sameness could be disorienting, except for the constant presence of Charon in the sky, which provides a fixed reference point that never moves. Temperature remains constant during the walk, and there is no wind to create chill or carry sound, making the environment feel static and unchanging in a way that no place on Earth ever feels. The atmosphere exists here, but at such low pressure that it cannot be sensed directly. And the lack of weather or atmospheric effects makes Pluto's surface feel more like being in space than being on a planetary surface. The pressure at the surface measures only about 10 microbars, roughly 100,000 times thinner than Earth's atmosphere, and this thin envelope extends upward for hundreds of kilometers, but never becomes dense enough to scatter light or create blue skies. As you approach within a few hundred meters of the polygon boundary, the feature becomes clearer and more defined than it appeared from a distance. The boundary consists of a trough or trench where the ice sits lower than the surrounding cell centers, and darker material has accumulated in this depression over time. The width of the trough appears to be several hundred meters across, making it more a zone of transition than a sharp line. And the depth looks to be anywhere from tens of meters to perhaps 100 meters below the surrounding plain level. Walking right up to the edge allows close examination of what has collected here. The darker material in the boundary trench appears reddish-brown, similar in color to the ancient highlands visible in other regions of Pluto. And it probably consists of tholins and other complex organic molecules that formed on the surface and then got swept into the boundaries by the ice convection. As fresh ice rises in the cell centers and spreads outward, any material sitting on the surface gets pushed towards the edges where it accumulates in these trenches. The boundaries therefore contain a concentration of the oldest and darkest material available on this otherwise bright and young plane, creating the subtle network of lines visible from orbit. Looking across the trench toward the next polygon cell shows that cell rising slightly higher in the center, confirming the convection pattern that creates these features. The next cell looks identical to the one you have been walking across, bright nitrogen ice stretching away toward its own distant boundaries, where it meets other cells in similar trenches. The pattern repeats across the entire expanse of Sputnik Planitia, creating hundreds of individual cells that collectively make up the plane. Each cell represents one convection current, one area where warm ice rises and spreads and cools and sinks, and together they create the active surface that makes this region unique. Standing at the boundary and looking back toward the lander shows how far you have walked, and the vehicle appears as a tiny speck on the white plane, barely visible against a uniform background. The distance covered measures just over 2 kilometers, but in the context of Sputnik Planitia's 1,000-kilometer extent, this represents only the smallest fraction of the plane's total area. Exploring every polygon boundary, every region of this single feature would take weeks or months of continuous walking, and that represents just one feature on one hemisphere of Pluto. The scale of what exists here becomes more apparent when traveling across the surface, rather than simply viewing it from orbit. The time spent examining the polygon terrain has filled the first extended surface exploration period, and now other features on Pluto's surface call for attention beyond this bright ice plane. The mountains visible on the horizon from orbit lie somewhere to the west and north, rising at the edge of Sputnik Planitia, where the nitrogen ice meets older terrain. Reaching those mountains will require a longer traverse across the plane, and the rover that landed with you will make that journey easier. Walking back toward the lander begins the return journey, retracing the path across the bright ice under Charon's unmoving gaze and the dim but steady light of the distant sun. The nitrogen ice plane remains still and silent around you, continuing its slow convection cycle that will outlast any human presence by hundreds of thousands of years. The rover moves across the nitrogen ice plane with smooth efficiency. Its wide wheels, designed for low gravity and soft surfaces, spreading the weight and preventing any significant sinking into the frozen nitrogen. You sit in the open cabin, watching the landscape pass by, and the cellular patterns of Sputnik Planitia roll underneath as the vehicle travels toward the western edge of the plane. The horizon ahead shows a slight change in texture, a hint that the flat expanse will eventually give way to different terrain where the mountains begin. The journey covers dozens of kilometers, and the rover's slow, steady pace makes the distance manageable without the exhaustion that walking would bring. The polygons beneath the rover wheels continue in their regular pattern, and you cross boundary trench after boundary trench, each filled with the same dark reddish-brown material that accumulated from surface processes over time. Occasionally, a polygon appears larger than usual, stretching 40 kilometers or more across, while others seem smaller and more compact, but all share the same basic structure of raised centers and depressed edges. The variation in size likely relates to the thickness of the ice layer at different locations and the strength of convection at different depths. Where ice is thicker or heat flows stronger, cells may grow larger or smaller to accommodate the conditions. As the rover continues westward, the mountains on the horizon gradually resolve from a vague textured line into actual peaks and ridges rising above the plain. The first features to become clear are the highest summits, which catch sunlight and stand out against the black sky behind them. These peaks reach 3,000 meters or more above the plain, and their slopes appear rough and angular rather than smooth or rounded by erosion. Water ice at Pluto's temperature remains hard and brittle, and mountains made of water ice can support steep slopes and sharp ridges without slumping or flowing the way ice does at warmer temperatures. The transition from flat plain to mountainous terrain happens over several kilometers, and the rover slows as the ground begins to rise and the nitrogen ice becomes less uniform beneath the wheels. Small ridges appear in the ice ahead, and patches of different colored material interrupt the previously consistent white surface. The change indicates the edge of the convection region, where the plain meets the older terrain that existed before Sputnik Planitia formed in this basin. The boundary between geologically active and geologically ancient appears as a gradual shift rather than a sharp line, and both terrains coexist in a transitional zone several kilometers wide. Stopping the rover near the base of the first significant mountain allows close examination of the terrain change, and you step down onto ground that feels subtly different from the nitrogen ice plain behind you. The surface here contains less pure nitrogen ice and more water ice mixed with rocky material, and the color shifts from bright white to a duller grey-tan shade. The texture underfoot becomes rougher, with more variation in hardness and more small-scale relief, and the smoothness of Sputnik Planitia disappears completely within a few dozen meters of leaving the plain edge. You have entered the mountain terrain, where water ice dominates, and the processes shaping the surface differ completely from those operating on the plain. Looking up at the nearest peak shows the mountain rising at a steep angle, its slopes covered in broken ice blocks and sharp ridges that suggest fracturing and faulting rather than smooth accumulation. The peak is part of a range that stretches north and south along the edge of Sputnik Planitia, and scientists named these mountains Hillary Montes, after Sir Edmund Hillary, who climbed Mount Everest on Earth. Other ranges nearby carry similar names honoring explorers and mountaineers, including Norgay Montes, named for Tenzing Norgay, Hillary's climbing partner on that famous Everest expedition. The names connect Pluto's geography to human achievement and give these distant frozen mountains an anchor in human experience. The climb toward higher elevation begins on foot because the slopes become too steep and broken for the rover to safely navigate. Each step upward requires attention to where you place your feet, and the low gravity helps enormously by making it easy to lift your weight and step up onto higher blocks. The water ice beneath your boots feels different from nitrogen ice, harder and more solid, with a texture that provides good grip and prevents slipping. The ice here will remain frozen for billions of years because temperatures never rise high enough to soften water ice, even slightly. And the mountains will erode only through impacts and radiation damage over geological timescales. Climbing higher brings increasing views back across Sputnik Planitia, and the plain spreads out below as an enormous expanse of bright ice, marked by the subtle cellular patterns you walked across earlier. The polygon boundaries create a network of lines across the plain, visible from this elevation as a web of darker trenches dividing the bright cells. The landing site is no longer visible due to distance, but you can see how the plain extends eastward toward the opposite shore, where different terrain rises beyond. Charon hangs in the sky above the plain, unchanged in position, and the stars surround the moon in their familiar patterns, undimmed by any atmospheric haze. Reaching a ridge about 1,000 meters above the plain requires steady climbing over broken ice and around obstacles, and the effort takes considerable time, despite the low gravity making physical exertion easy. From this elevation, the view expands dramatically, and you can see mountain peaks extending north and south along the plain's edge, some rising even higher than your current position. The highest summits reach over 3,000 meters, rivaling significant mountains on Earth despite Pluto's small size. The peaks appear sharp and angular, with no softening from erosion or ice flow, and their profiles look jagged against the black sky. Looking westward, away from Sputnik Planitia, shows a completely different landscape beyond the mountains, and this terrain appears rougher and darker than the bright plain below. The land beyond consists of ancient highlands covered in impact craters and varied terrain features, and the contrast between the young, smooth plain and the old, rugged highlands demonstrates Pluto's complex geological history. The mountains themselves form a boundary between these two worlds, rising as a barrier between active and ancient surfaces. The cause of the mountain formation remains uncertain, but the compression of ice and tectonic forces probably played roles in uplifting these ranges. The summit of the peak you are climbing appears above, and the final approach requires careful navigation around ice blocks and across steep sections where the footing becomes less certain. Low gravity helps prevent falls from becoming dangerous, but maintaining 3 points of contact with the ice ensures safety and steady progress. The peak itself appears as a narrow ridge rather than a broad summit, and when you finally reach the top, the views extend in all directions, with nothing blocking the sightlines. Below to the east lies Sputnik Planitia in all its bright glory, while to the west, the darker highlands extend toward the horizon. And to north and south, other peaks of Hillary Montes and Norgay Montes continue the mountain chain. Standing on this summit places you at one of the highest elevations on Pluto's near hemisphere, and the position offers a perspective on the world's geography that was impossible from the plane's surface. The mountains here at the edge of Sputnik Planitia represent some of the youngest features in the solar system, likely formed within the last few 100 million years, and they demonstrate that Pluto remained geologically active long after a world this small should have frozen solid. The existence of these mountains surprised scientists when New Horizons revealed them, and they indicated that Pluto's interior retained enough heat to drive geological processes that could build mountain ranges. The composition of these mountains matters because water ice at 40 Kelvin is as strong as rock, and it can support the weight of 3,000-meter peaks without flowing or collapsing under its own weight. On a warmer world, ice mountains would slump and flatten over time. But here, the cold preserves every feature indefinitely. The ice contains no liquid water and never will, unless Pluto somehow moves closer to the Sun, an event that will never occur under natural circumstances. The mountains are permanent structures on human timescales, and they will look essentially the same a million years from now as they do at this moment. After spending time at the summit, examining the views and taking measurements of the terrain visible from this vantage point, the descent begins back down the slopes toward the base of the mountain range. The return trip proves easier than the climb because low gravity makes controlled descent simple. And you can move quickly while still maintaining safety by choosing each step carefully. The water ice under your feet remains solid and supportive, and the broken blocks that made climbing challenging now provide convenient steps and handholds for the descent. Within a relatively short time, you return to the transitional zone where water, ice, mountains meet nitrogen ice plain. The rover waits where you left it, and climbing back into the cabin prepares you for the next leg of the journey across Pluto's surface. The mountains have been explored, and their nature understood, and now the highlands beyond call for attention, offering terrain completely different from both the smooth plain and the sharp peaks. Starting the rover and turning west begins the journey into the ancient cratered regions, where Pluto's surface reveals its history through impacts that happened billions of years ago. The transition happens gradually as the rover climbs away from Sputnik Planitia, leaving the bright ice behind and entering the darker, older landscapes that cover much of Pluto's surface. The rover climbs steadily through the passes between peaks, finding routes that avoid the steepest slopes and most broken terrain, and the mountains gradually give way to highlands that extend westward. The ground under the wheels changes from predominantly water ice to a mixture of water ice and darker materials, and the color of the landscape shifts from grey-white to tan and brown shades. The texture becomes rougher with every kilometer traveled, and features absent from Sputnik Planitia begin to appear in the terrain ahead. The first impact crater comes into view as a circular depression about 2 kilometers across, its rim rising slightly above the surrounding ground, and its floor lying in shadow. Approaching the crater allows close examination of impact features that have been absent from your exploration so far, and the rover stops near the rim so you can step out and walk to the edge. The rim rises perhaps 100 meters above the surrounding terrain, creating a low ridge that circles the entire depression, and blocks of ice ejected during the impact lie scattered around the outer slopes. Looking down into the crater shows the floor lying several hundred meters below the rim, and the interior appears shadowed because the low sun angle cannot illuminate the depths. The crater appears ancient, based on its softened profile and the lack of sharp features, but without knowing the impact rate on Pluto, estimating exact age remains difficult. Walking along the crater rim provides different perspectives on the feature, and you can see how the circle is not perfect, but shows irregularities and gaps, where later events modified the original shape. Smaller craters overlap this larger one in several places, demonstrating that impacts continued after the initial crater formed, and that this terrain has been accumulating craters for a very long time. The density of craters in this highland region contrasts sharply with Sputnik Planitia's complete absence of impacts, and the difference shows how active surfaces erase their impact history, while inactive surfaces preserve it. The highlands here stopped being geologically active billions of years ago, and since then, impacts have been the primary process altering the surface. Descending into the crater requires careful navigation down the inner wall, where the slope angle increases and loose ice blocks create obstacles and hazards, despite the low gravity. The wall shows layers in places where ice of different composition or different ages stacked during the crater's formation or afterward through frost deposition. The deepest parts of the crater floor never receive direct sunlight because the sun's low angle cannot reach into the depression, and these permanently shadowed regions remain even colder than the surrounding landscape. Instruments showed temperature in the shadowed crater floor dropping below 35 Kelvin, several degrees colder than the sunlit surface. And this temperature difference allows certain ices to remain stable in craters even if they sublimate away from sunlit areas. The crater floor appears relatively smooth and covered in fine frost deposits that give the surface a soft appearance different from the rougher terrain outside the crater. This frost likely consists of nitrogen or methane ice that migrated into the cold trap created by the permanent shadow and deposited as a thin layer over the original impact debris. Walking across the floor demonstrates that the frost is indeed thin, perhaps only centimeters deep, and beneath it, the harder surface of the original crater floor remains intact. The silence and cold in this shadowed depression feel more intense than on the open surface, and the psychological effect of being in a place where sunlight never reaches adds to the alien quality of the environment. Climbing out of the crater takes you back into sunlight, and the temperature rises immediately to the ambient 40 Kelvin that characterizes most of Pluto's sunlit surface. Looking back at the crater from the outer rim shows how the depression interrupts the terrain and creates local variation in an otherwise relatively flat highland region. Beyond this crater, many others appear scattered across the landscape, ranging from small pits a few hundred meters across to larger structures several kilometers in diameter. The highland region consists of a cratered plain that extends for hundreds of kilometers in multiple directions, and exploring it fully would require weeks of traversing and examining individual features. The rover journey continues across the highlands, passing crater after crater, and occasionally crossing ridges or low hills that add relief to the landscape. The surface composition varies from place to place, with some areas showing cleaner water ice and others displaying darker material that gives the ground a reddish-brown cast. The darker material represents tholins, complex organic molecules formed when ultraviolet light and cosmic radiation break apart methane and nitrogen molecules and allow them to recombine into larger structures. Tholins accumulate slowly over millions of years, and their presence indicates surface age, because younger surfaces have not had time to accumulate significant quantities. Hours of driving bring the rover to a region where the terrain changes again, and ahead, the ground takes on a distinctly darker appearance that extends across the landscape as far as you can see. This dark region represents one of Pluto's most distinctive features, a vast area of ancient, heavily cratered terrain that absorbed enough radiation over billions of years to develop a deep reddish-brown color. The boundary between lighter highlands and darker terrain appears gradual, with the color deepening progressively over several kilometers rather than changing abruptly. The transition indicates that the processes creating the dark material operate over wide areas and that the coloration depends on exposure time and radiation dose accumulated over geological timescales. Entering the dark terrain creates an immediate visual change, and the landscape around the rover shifts from tan and grey to deep reddish brown that resembles rust or dried blood in colour. The material underfoot remains water ice mixed with tholins, and the mechanical properties do not change significantly, despite the colour difference. What has changed is the surface chemistry, with simple molecules transformed into complex organic compounds through photochemical reactions. The dark material absorbs sunlight more efficiently than clean ice, and this absorption creates slight temperature differences that may affect ice behavior and sublimation rates over long timescales. Stopping in the heart of the dark region allows you to step out and examine the material up close, and the reddish-brown color appears even more pronounced when standing directly on it. The texture looks similar to other ice terrain you have crossed, with a rough granular surface showing cracks and small-scale variations. Kneeling down and looking closely at the ice shows the color penetrates the surface rather than existing as a thin coating, indicating that the tholins are mixed throughout the upper layers of ice rather than simply depositing on top. The mixing probably occurs through sublimation and redeposition cycles, where ice vaporizes, mixes with tholins in the gas phase, and then refreezes with the organic molecules incorporated. The dark terrain extends north toward Pluto's equator, and this particular region is named Cthulhu Macula after the fictional cosmic entity created by writer H.P. Lovecraft, following the naming theme that connects Pluto's features to underworld mythology and figures. Cthulhu Macula spans roughly 2,900 kilometers across, making it one of the largest dark regions on Pluto's surface. And its position near the equator means it receives more direct sunlight than polar regions. The increased sunlight drives stronger photochemical reactions and creates more tholins, which contributes to the region's darkness. The ancient surface age, indicated by heavy cratering, shows this terrain has been exposed to space radiation for billions of years, allowing continuous tholin production and accumulation. Walking across the dark material creates an odd visual experience because the ground appears much darker than anything you encountered on Sputnik Planitia or even in the lighter highlands. The contrast between this terrain and the bright nitrogen ice plain demonstrates the diversity of Pluto's surface, and the fact that a world this small displays such variety suggests complex geological and chemical histories. The darkness here does not indicate different temperatures or different gravity, only different surface chemistry, and the ice beneath your feet remains as solid and cold as ice anywhere else on Pluto. Returning to the rover and continuing the traverse takes you deeper into Cthulhu Macula, and the uniform dark color continues for dozens of kilometers without significant variation. Craters appear regularly in this terrain, some with bright rays of cleaner ice radiating from their centers, where impacts excavated material from beneath the tholin-rich surface layers. These bright-rayed craters stand out dramatically against the dark background, and they indicate that fresher ice exists below the surface, while tholins concentrate in the uppermost layers. The rays themselves will darken over time as radiation processes the fresh ice and creates new tholins, eventually causing the bright features to fade back into the background darkness. The journey across Cthulhu Macula takes many hours, and the landscape maintains its dark character throughout the traverse, with only minor variations in shade and texture. Some areas appear almost black, while others show more of the reddish-brown component, and these color differences probably relate to slight variations in tholin composition or concentration. The consistent darkness can become monotonous after extended travel, and the visual sameness makes distance difficult to judge without instruments. The horizon remains close due to Pluto's small radius, and each new section of terrain looks much like the last, creating a feeling of traveling without making progress. Eventually, the terrain ahead begins to show change, and lighter-colored areas appear mixed with the dark terrain, breaking up the uniform appearance that characterized the previous hours of driving. These lighter patches consist of fresher ice that either avoided heavy tholin accumulation or got deposited more recently and has not yet darkened. The mixing of light and dark terrain creates a mottled appearance, and the variation provides visual relief after the extended period of uniform darkness. The transition suggests movement away from the heart of Cthulhu Macula toward its edges where the dark region meets other terrain types. Ahead on the horizon, unusual features begin to appear as linear ridges oriented roughly north to south, and these features look different from anything encountered previously on the journey. The ridges appear to be tall and narrow, rising like blades or fins from the surface, and their regular spacing and alignment suggest formation through some organized process rather than random accumulation. The features represent Pluto's strangest terrain, and reaching them will require several more hours of rover travel across the transitional zone between Cthulhu Macula and the Blade formations. The rover continues toward these peculiar features, and the landscape around you gradually changes from dark cratered plains to rougher terrain where the blade ridges begin to emerge from the ground. The blade ridges rise from the landscape ahead like enormous frozen fins, each standing hundreds of meters tall and aligned in parallel rows that extend beyond the visible horizon. The rover approaches the first ridge system slowly, and the scale of these features becomes apparent as you draw closer and the height increases relative to your position. These formations are called penitentes, named after a similar but much smaller phenomenon that occurs in high-altitude snowfields on Earth, where ice sublimation creates blade-like ridges. On Pluto, the same basic process operates, but on a vastly larger scale, creating methane ice blades that dwarf any comparable feature elsewhere in the solar system. The spacing between individual ridges measures several hundred meters, and the blades themselves appear sharp-edged and steep-sided, with slopes approaching vertical in many places. The composition consists primarily of methane ice, rather than the water ice that dominates most of Pluto's terrain. And methane behaves differently from water ice under Pluto's conditions. Methane sublimates more readily than water ice, turning directly from solid to gas without passing through a liquid phase. And this sublimation process carves the ice into these dramatic blade formations over millions of years. The orientation of the blades relates to the angle of sunlight, with the ridges aligned so that the sun's rays strike them at specific angles that promote blade formation rather than uniform erosion. Driving the rover between two blade ridges requires careful navigation because the troughs between blades contain broken ice, debris, and shadows that obscure obstacles. The walls of the blades rise on either side, creating a canyon effect that blocks much of the sky and makes the environment feel enclosed. despite being on an open planetary surface. Looking up at the blade edges overhead shows sharp crests that catch sunlight, while the trough floor remains in deep shadow. And the temperature difference between sunlit and shadowed areas creates thermal stresses that may contribute to ice fracturing. The silence in this strange landscape feels even more profound than elsewhere, because the blade walls create a sense of acoustic space despite the lack of atmosphere to carry sound. Stopping the rover and stepping out into the trough allows closer examination of the blade walls, and the methane ice here shows a different texture than the water ice encountered in other regions. The ice appears more crystalline and reflective, with facets that catch light and create glints and sparkles on the sunlit sections. The surface feels similar under your gloves when you touch it, hard and cold and solid. But the knowledge that this is methane, rather than water ice, adds to the alien quality of the environment. On Earth, methane exists as a gas, except under extreme conditions. But here, it forms mountains and blades and permanent geological features. The climb up one of the blade walls proves challenging because the slopes are steep, and the low gravity, while helpful, cannot completely compensate for the angle and the smooth ice surface. Finding handholds and footholds requires searching for irregularities and cracks in the ice, and progress upward is slow and requires concentration. The blade wall rises several hundred meters from trough to crest, and reaching the top takes considerable time and effort despite the reduced weight you feel in Pluto's weak gravity. Each meter gained brings new views of the surrounding terrain, and the parallel nature of the blade field becomes more apparent as you climb higher. Reaching the crest of the blade ridge provides a spectacular view across the field of parallel ridges that extends north and south for as far as you can see. Each blade rises like a frozen wave, and the regular spacing creates a rhythmic pattern across the landscape that looks almost artificial in its organization. The blade field occupies a region called Tartarus Dorsa, named after the deepest part of the underworld in Greek mythology. And this region represents some of the most unusual terrain found anywhere on Pluto, or indeed anywhere in the explored solar system. The blades here reach heights exceeding 500 meters in places, taller than many skyscrapers on Earth, and they maintain their sharp profiles without softening or rounding. The formation process for these enormous blades involves sublimation erosion, where methane ice turns directly from solid to gas and escapes into the atmosphere. The sublimation rate depends on temperature, sun angle, and local conditions, and areas that receive slightly more sunlight sublimate faster than areas in shadow. Over millions of years, this differential sublimation carves the ice into blade formations, with the ridges representing areas that sublimate more slowly, and the troughs representing areas where ice removal happened more quickly. The sun angle at Pluto's equatorial regions creates the geometry needed for blade formation, and similar features do not appear at higher latitudes where sun angles differ. Walking along the crest of the blade ridge requires balance and care, because the top is narrow, often only a few meters wide, and drops fall away steeply on both sides. The view from this elevated position shows the full extent of the blade field, and you can count dozens of parallel ridges extending toward the horizon in both directions. Between each blade lies a trough similar to the one you climbed from, and the repeating pattern creates a landscape unlike anything on Earth or any other world yet explored. The methane ice that forms these blades will remain frozen for billions of years, and the features will persist essentially unchanged until Pluto's orbit carries it through some future configuration that alters the thermal conditions. The descent from the blade crest proves easier than the ascent because you can see the path ahead and use gravity to assist the downward motion, though care remains necessary to avoid slipping on the smooth ice. Returning to the rover at the trough floor ends the blade climbing exploration, and driving continues through the blade field on a course that follows the troughs where navigation is possible. The journey through Tartarus Dorsa takes many hours because the blades extend across a large area, and finding routes through the maze of ridges and troughs requires constant attention to the terrain ahead. Eventually, the blade field begins to thin, and the ridges become shorter and more widely spaced, indicating movement toward the boundary of the formation region. The terrain beyond the blades appears as mixed highlands with varied textures and colors, and this diversity suggests a transition zone where different geological regions meet and interact. Leaving the blade field behind brings the rover into more open terrain, where navigation becomes simpler and the views extend farther. The blade ridges recede behind you, visible as parallel lines on the landscape, and ahead, new features wait to be explored. The transition zone between major terrain types on Pluto offers opportunities to see how different regions interact and how boundaries develop between areas with different characteristics. The rover travels across ground that shows elements of multiple terrain types mixed together, with patches of dark tholin-rich material adjacent to cleaner ice deposits and areas of rough cratered terrain next to smoother sections. The boundaries between these different surface types sometimes appear sharp and sometimes gradual, and the variation demonstrates the complexity of processes operating on Pluto's surface over geological time. One particularly interesting boundary appears ahead, where bright nitrogen ice from an extension of Sputnik Planitia meets darker ancient highlands, similar to those encountered earlier. The contact between these two terrain types creates a visible line across the landscape, and driving toward this boundary allows close examination of how young, active terrain interacts with old, inactive terrain. The rover reaches the contact zone and stops directly on the boundary line, allowing you to step out with one foot on bright nitrogen ice and the other on dark, ancient highlands, physically straddling two different geological worlds. The temperature difference between the two terrain types is negligible, both sitting at approximately 40 Kelvin, but the visual and compositional differences are dramatic. The nitrogen ice appears bright and smooth, with subtle cellular patterns starting to emerge, while the highland terrain shows dark colors, rough texture, and impact craters that mark its ancient surface. The boundary itself appears as a gradual transition zone several meters wide, where nitrogen, ice, and darker material mix before separating into distinct regions. The contact likely formed as nitrogen ice flowed or sublimated and redeposited at the edge of its stable region, creating the current boundary configuration. Looking along the boundary line shows it extending in both directions across the landscape, and the contact follows topographic contours in places while cutting across terrain in others. The behavior of the boundary reveals information about how nitrogen ice moves and accumulates, responding to temperature, slope, and subsurface conditions. In low areas, nitrogen ice pools and thickens, while on high ground, the ice may be absent entirely, having sublimated away or never accumulated in the first place. The boundary represents the current equilibrium position, where deposition and sublimation balance, though this position may change over Pluto's long orbital period as distance from the Sun varies. Walking along the boundary for several hundred meters shows variations in how the two terrain types meet, and some sections display nitrogen ice fingers extending into the highlands, while other sections show highland material protruding into the ice. These irregularities suggest dynamic interaction over time rather than a simple static contact, and the mixing indicates that the boundary moves or fluctuates in response to changing conditions. The timescale for these changes likely measures in thousands or millions of years, far too slow to observe directly, but the evidence preserved in the terrain demonstrates that movement occurs. After exploring several boundary regions and documenting the interactions between different terrain types, you return to the rover and prepare for the next phase of the journey. The Sun's position in the sky has shifted slightly during the long exploration period, and although Pluto's rotation is slow, taking 6.4 Earth days to complete one turn, enough time has passed that the Sun has moved measurably along its arc. The movement serves as a reminder that time continues even in this frozen, distant world, and that day will eventually give way to night, despite the long hours each phase lasts. The Sun continues its slow progression across the sky, and after many hours of exploration, the angle of light falling on Pluto's surface begins to shift noticeably toward what will eventually become sunset. The transition from full day to twilight takes much longer here than on Earth, because Pluto's rotation period stretches each day to 6.4 Earth days, making one Pluto day equal to about 153 Earth hours. The Sun moves so slowly that its position seems almost fixed, changing only slightly over the course of hours, and the landscape remains in steady illumination without the rapid shifts, familiar from Earth's 24-hour cycle. As the Sun drops lower toward the horizon, the quality of light changes subtly, and features on the surface begin to cast longer shadows that reveal textures and relief invisible under higher sun angles. The mountains in the distance show more definition, with their western faces catching direct sunlight, while their eastern slopes fall into shadow. And the contrast creates a three-dimensional quality absent when the Sun sits higher in the sky. The cellular patterns on distant sections of Sputnik Planitia become more visible as the boundaries cast shadows that emphasize the trenches, and the landscape reveals details that were present all along but needed the changing light to become apparent. Driving the rover toward a good vantage point for observing sunset brings you to a low ridge that offers clear views toward the western horizon, where the Sun will eventually descend. The ridge rises only a few hundred meters above the surrounding terrain, but the elevation provides an unobstructed view across kilometers of landscape in the direction of the approaching sunset. Stopping here and stepping out of the rover allows you to watch the slow process of day transitioning toward night, and you settle in to observe the changing conditions as Pluto's rotation carries the Sun toward the horizon. The atmosphere, barely noticeable during full day, begins to reveal itself as the sun angle becomes more oblique and light passes through longer paths of atmospheric gas. Pluto's atmosphere extends upward for hundreds of kilometers despite its low surface pressure, and when sunlight passes through this extended envelope at a shallow angle, haze becomes visible as faint layers in the sky. The haze consists of tiny particles formed through photochemical reactions, where ultraviolet light breaks apart methane molecules and allows them to recombine into complex organic compounds that condense into microscopic droplets or particles suspended in the thin air. The haze layers appear as delicate blue bands, stacked one above another in the direction of the sun, and the blue color comes from the way small particles scatter light, preferentially scattering shorter blue wavelengths while allowing longer red wavelengths to pass through. The same physics creates Earth's blue sky, though the mechanism operates differently in Pluto's thin atmosphere, and the result is hauntingly beautiful. The layers become clearer as the sun drops lower, and you can count more than a dozen distinct bands extending upward from the horizon, each representing a region of slightly different particle concentration or composition at different altitudes. The sun itself remains intensely bright, despite the distance, appearing as a brilliant point that hurts to look at directly, even though it provides only a fraction of the light it delivers to Earth. The solar disk appears small from Pluto, subtending only about 1 arc-minute compared to the half-degree the sun shows from Earth, and the reduced size makes it look more like an extremely bright star than the warm, familiar disk seen from the inner solar system. The intensity concentrated in that small point creates sharp shadows and bright highlights, despite the overall dim illumination. And the contrast between light and shadow becomes more pronounced as sunset approaches. As the sun touches the horizon, the haze layers glow with scattered light, and colors appear that were absent during the day when the sun's angle was higher. Orange and yellow tones mix with the blue haze, creating gradients that shift between warm and cool colors across the sky. The effect resembles sunset on Earth, but with differences that mark this as an alien world, including the sharpness of the horizon without atmospheric distortion and the visibility of stars in the sky, even while the sun remains partially above the horizon. The thin atmosphere cannot brighten the sky enough to obscure stars, and the full dome of space remains visible throughout the sunset process. The temperature, already cold, begins to drop further as the sun's light diminishes, though the change amounts to only a few degrees because Pluto's surface temperature is so low that the difference between day and night becomes almost negligible. Instruments show the surface cooling from 40 Kelvin toward 37 or 38 Kelvin, a change that would be imperceptible without instruments, but that has implications for atmospheric behavior. Gases that remain stable at 40 Kelvin may begin to freeze out at 37 Kelvin, and the atmosphere can change composition and pressure as temperature drops and certain gases condense onto the surface or sublimate from it. The sun slips below the horizon gradually, taking nearly an hour to disappear completely. Because the motion is so slow, and because the low sun angle means the disk must travel a long arc before it fully sets. The last light lingers on the haze layers long after the sun itself vanishes, and the sky glows with scattered illumination that creates an extended twilight period. Earth's twilight lasts minutes to an hour, depending on latitude and season. But on Pluto, the transition from day to night stretches for many hours as the thin atmosphere continues scattering the last sunlight, and the slow rotation means the sun takes a long time to drop far enough below the horizon that its light no longer reaches the upper atmosphere. During the extended twilight, the landscape around you remains dimly visible, illuminated by the glow in the western sky and by starlight that becomes stronger as the sunset fades. Charon hangs in its usual position in the sky, and the moon's surface catches sunlight even after the sun has set from your position on Pluto's surface, because Charon orbits high enough that it can see the sun even when you cannot. The moon glows as a grey crescent in the darkening sky, and the illuminated portion provides enough light to cast faint shadows on the ground around you, adding another source of illumination to the starlight and twilight glow. The stars emerge not with the sudden visibility they show on Earth after sunset, but through a gradual increase in prominence as the sky darkens from twilight to full night. The brightest stars remain visible throughout the day on Pluto because the atmosphere cannot scatter enough light to wash them out. But the fainter stars become easier to see as the sky background darkens. The Milky Way becomes obvious during twilight, appearing as a pale band crossing the sky from horizon to horizon, and its structure shows detail that would be visible from Earth only under the darkest skies, far from any artificial lights. The temperature continues its slow decline, and frost begins to form on surfaces that radiated heat into space during the day and now cool below the freezing point of atmospheric gases. Nitrogen frost appears as a thin white coating on rocks and equipment, depositing molecule by molecule as nitrogen gas touches cold surfaces and condenses. The process happens slowly and subtly, but over the course of several hours, the accumulation becomes visible as surfaces gradually whiten with new frost. The same process operates across Pluto's entire night side, with atmospheric gases freezing out and depositing on the surface during the long night, then sublimating back into the atmosphere when daylight returns. As full darkness arrives and the last twilight fades from the western horizon, the landscape transforms into a nighttime environment that will last for over 3 Earth days before sunrise begins the reverse process. The stars provide enough light to see general features and shapes, and Charon's crescent adds localized illumination, but fine details disappear into darkness that will persist until the sun rises again. The temperature has stabilized at its nighttime value several degrees below the daytime temperature, and conditions will remain in this state for many hours to come. You have witnessed Pluto's sunset, a slow, majestic transition from day to night. And now the long night begins. The darkness that settles over Pluto's landscape after sunset differs from night on Earth in fundamental ways that become apparent as your eyes adjust and the environment reveals itself. The absence of atmospheric scattering means no diffuse glow softens the shadows, and objects appear either directly illuminated by starlight and Charon light or completely black, depending on their orientation. The contrast between light and dark is absolute, with no gradual transition zones, and the effect creates a stark visual environment where depth perception becomes challenging without the subtle lighting cues familiar from Earth's atmospheric effects. Charon dominates the sky from your position on Pluto's near hemisphere, and the moon hangs motionless exactly where it appeared during daylight hours, because the tidal locking between Pluto and Charon means each body keeps the same face toward its partner. Charon never rises or sets from this location, never moves across the sky, never changes position relative to the horizon or the stars, remaining instead as a fixed feature in the heavens above. The moon's apparent size is impressive, spanning about 4 degrees of arc, compared to the half degree that Earth's moon shows from Earth's surface, making Charon appear 8 times larger in diameter and 64 times larger in area. The current lighting geometry shows Charon as a crescent because the sun illuminates only part of the moon from your vantage point on Pluto's night side. The crescent appears grey, with subtle, darker, and lighter regions visible on the illuminated portion. And these markings represent surface features, including Charon's dark northern polar region and lighter equatorial areas. The illuminated crescent provides measurable light that falls on Pluto's surface around you, and this Charon light creates a faint secondary illumination that adds to the starlight. The combination allows you to see the general shapes of landscape features, though fine details remain lost in the darkness. The stars fill every part of the sky not occupied by Charon, and their number and brightness exceed what even the darkest Earth skies can show, because no atmosphere interferes with the light, and no scattered light washes out faint stars. The Milky Way crosses the sky as a luminous river of light, and dark dust lanes within our galaxy appear as black gaps in the star fields, where intervening material blocks light from more distant stars. Individual stars show colors visible to the unaided eye here, where no atmospheric distortion mutes the tints, and blue stars, white stars, yellow stars, orange stars, and red stars appear in their true shades, creating a subtle color palette across the heavens. Familiar constellations appear in recognizable patterns, despite the 5.9 billion kilometer distance from Earth. And you can identify Orion, the Big Dipper, Cassiopeia, and other star groups that have guided navigators and inspired observers throughout human history. The stars in these constellations are so distant that even Pluto's remote location makes negligible difference to their positions, and the patterns look essentially identical to how they appear from Earth. The only significant difference is the Sun, which from Pluto appears as a very bright star in the constellation Taurus. Easily the brightest star in the sky, but star-like nonetheless, rather than showing a visible disk. Locating Earth in the sky requires finding the Sun first, and then knowing that Earth lies very close to that bright point. Completely invisible because the distance makes Earth's reflected light too faint to see, and the proximity to the Sun's glare overwhelms any possibility of detection. Every human who has ever lived, every city and ocean and mountain range on Earth exists on that invisible world, near that bright star, and the separation of almost 6 billion kilometers renders all of human civilization completely undetectable from where you stand. The feeling of isolation that comes from contemplating this distance is profound, though the emotional content of that feeling varies for each individual who experiences it. The silence of Pluto's night is complete in a way that silence on Earth never achieves, because Earth always has some sound, whether wind or water or distant activity, while Pluto has none. The atmosphere is too thin to carry sound waves, and no geological activity creates rumbles or vibrations, and no life exists to produce biological sounds. The absolute silence creates an unusual sensory environment where the absence of auditory input becomes noticeable. And some observers report that the silence itself seems to acquire presence, though this represents a psychological response to unusual sensory conditions rather than an actual sound. Walking across the dark landscape requires attention to footing because the limited light makes surface irregularities difficult to see, and the sharp shadows cast by starlight and Charon light create confusing visual patterns. Each step needs to be placed carefully, and the slow, deliberate pace enforced by the lighting conditions actually makes navigation easier in the low gravity, because rushing would lead to stumbles or missteps. The ground beneath your feet feels the same as during daylight, hard and cold and solid, and the darkness does not change the physical properties of the surface, even though it changes your perception of the environment dramatically. The rover provides a beacon for navigation because its lights remain visible from long distances in the clear air. And the artificial illumination creates a pool of brightness around the vehicle that contrasts sharply with the natural darkness. Returning to the rover allows rest and shelter, and the cabin's lights provide normal visibility that makes tasks and observations easier than they would be in pure starlight. The contrast between the lit cabin and the dark landscape outside becomes extreme, and looking out the windows shows mostly reflections of the cabin interior rather than views of the surroundings, until your eyes adjust to the darkness again. The duration of night on Pluto stretches ahead for over 3 Earth days, approximately 76 hours of darkness, before the sun begins to rise in the east and bring daylight back to this location. The long night results from Pluto's rotation period of 6.4 Earth days, which means each day and each night lasts roughly 3.2 Earth days. The slow rotation stems from the tidal interaction between Pluto and Charon, which not only locked the two bodies in mutual synchronous rotation, but also slowed both their spins to the current period. Without Charon's influence, Pluto might rotate much faster, but the gravitational coupling transferred rotational energy out of both bodies over billions of years until equilibrium was reached. Time during the long night passes slowly because the unchanging conditions provide few markers to segment the hours. And without consulting instruments, it becomes difficult to judge whether minutes or hours have passed. The stars move gradually across the sky due to Pluto's rotation, but the motion is so slow that casual observation cannot detect it, and Charon remains fixed in position, providing no time reference. The psychological experience of such a long night varies among observers, with some finding the extended darkness peaceful and others experiencing it as monotonous or disorienting. The intellectual knowledge that sunrise will eventually come provides reassurance even as the darkness continues hour after hour. The temperature remains stable throughout the night at its minimum value, showing no further decline once the initial post-sunset cooling finishes and equilibrium is reached between heat lost to space and heat retention in Pluto's interior and surface layers. The temperature will not rise again until sunrise begins and sunlight starts warming the surface. And this warming will take many hours to manifest because the sun's energy at Pluto's distance is weak and surface materials change temperature slowly. The cycle of day and night drives atmospheric changes as well, with gases freezing out during night and sublimating during day. And this cycle may cause atmospheric pressure to vary over the course of Pluto's long rotation period. Looking at Charon's crescent in the dark sky reminds you that the moon itself experiences the same day-night cycle as Pluto, with each Charon day and night lasting 6.4 Earth days as well, because of the tidal locking. The illuminated crescent you see from Pluto's night side represents the day side of Charon, where the sun currently shines, and from that sunlit region of Charon's surface. Pluto would appear as a crescent as well, hanging motionless in Charon's sky, just as Charon hangs motionless in Pluto's. The two worlds mirror each other in their mutual orbit, forever facing each other across the 19,500 kilometers that separate them. The concept of being on Pluto's far hemisphere, where Charon never appears above the horizon, creates an interesting thought experiment about how the night sky would differ in that region. Without Charon's light, the night would be darker, illuminated only by stars and the distant planets that appear star-like at this distance. The inhabitants of Pluto's far side, if any existed, would never see Charon at all and would experience a simpler sky without the large grey moon that dominates the near hemisphere's view. The difference between near-side and far-side environments demonstrates how local conditions on a small world can vary dramatically depending on position relative to tidal locking. After many hours in darkness, you prepare to drive the rover toward new regions to continue exploration, and the vehicle's lights create a moving bubble of visibility in the dark landscape. The journey will continue through the night because exploration does not require daylight when artificial lighting provides visibility, and the long night offers plenty of time to cover distance and examine features that can be observed regardless of solar illumination. The stars wheel slowly overhead as Pluto rotates, and Charon maintains its vigil in the sky, and the rover moves across the frozen terrain, carrying you deeper into the night-side regions, toward areas not yet explored during this mission. The rover travels through the darkness, guided by lights and navigation instruments, and the landscape revealed in the forward beams appears in stark white and black tones, without the subtle shading that natural daylight provides. Craters pass by, their rims catching the light while their floors remain in deep shadow. And rougher terrain creates alternating patterns of brightness and darkness as elevated areas reflect the rover lights and depressions fall into shade. The journey continues for hours, covering distance that would have been difficult to traverse during the bright periods when visual reference points and navigation would be easier. But the instrument guidance makes night travel feasible, despite the darkness. The terrain gradually changes as the rover moves eastward and slightly northward, entering a region where the cratering density decreases, and the surface shows different textures than the heavily impacted highlands that dominated previous areas. The ground appears smoother in the rover lights, with fewer large craters and more subtle variations in elevation and surface material. This region represents one of Pluto's intermediate-aged terrains, younger than the ancient highlands but older than Sputnik Planitia, and the actively renewing surfaces, and the geology shows characteristics of both ancient and recent processes mixing in complex ways. After many hours of night driving, you stop the rover and step out to observe the sky from this new location. And the view remains similar to what you saw earlier, with Charon in the same position and stars filling the darkness. The consistency of the sky might seem monotonous, but the unchanging aspect also provides stability and constancy that can feel reassuring in an alien environment. The stars never set and never rise from this latitude, instead wheeling slowly around the celestial pole in great circles that repeat every 6.4 days. And the familiar patterns provide orientation and reference even in the darkness. Looking toward the eastern horizon reveals the first subtle change in many hours, a very faint lightening of the sky in the direction where the sun will eventually rise and bring daylight back to this region. The brightening is barely perceptible, a slight reduction in the perfect blackness that represents the earliest beginning of astronomical twilight. And it indicates that sunrise is still many hours away, but has transitioned from future event to approaching reality. The slow rotation means this twilight period will extend for a very long time before the sun actually appears. And watching the progression of pre-dawn light offers a way to mark time through the latter part of the long night. The temperature remains at its nighttime minimum, with no sign yet of warming, and the frost that accumulated on surfaces during the night hours continues to coat exposed materials with thin, white deposits. The frost crystals are tiny, too small to see individually without magnification, but their collective effect creates visible whitening of surfaces that were darker during the day. Some of this frost will sublimate when sunlight returns, while some may persist in shadowed areas or may get buried by later frost deposits in subsequent night cycles. The movement of volatiles between atmosphere and surface represents one of the active processes continuing on Pluto despite the world's small size and low temperature. The decision to wait for sunrise means settling in at this location and watching the slow progression of twilight as the eastern horizon gradually brightens over the next hours. The process cannot be rushed, and attempting to drive toward the sunrise would make little difference because the day-night line moves slowly across Pluto's surface, and driving at rover speeds would not significantly change the timing of when sunlight reaches your location. Patience becomes necessary, and the waiting period offers time to observe the sky changes and the subtle shifts in lighting that accompany the approach of dawn. The first improvement in eastern sky brightness remains subtle for a long time, with the change happening so gradually that continuous observation makes it difficult to notice. And only looking away for an hour and then looking back reveals that the sky has definitely brightened. The stars near the eastern horizon begin to fade first, washed out by the increasing sky glow, while stars higher in the sky remain clearly visible. The progression mimics dawn on Earth, but stretched across a much longer time frame, and watching it creates an unusual perspective on how rotation and sunrise interact to create the daily cycle experienced on any rotating world. Charon's appearance begins to change as well, with the crescent growing slightly as more of the moon's surface becomes illuminated by the approaching sun. The change is slow, but visible over the course of hours, and the increase in illuminated area means more Charon light falls on Pluto's surface around you, adding to the growing ambient light from the brightening sky. The moon will become fully illuminated from your vantage point once the sun rises, because then both Pluto and the sun will be on the same side of the moon, and Charon will appear as a full grey disk rather than a crescent. The twilight strengthens gradually, and the eastern horizon develops a glow that spreads upward into the sky, creating a dome of lighter sky that contrasts with the still dark sky in other directions. The atmospheric haze layers become faintly visible again, catching the first sunlight that reaches the upper atmosphere before the sun itself becomes visible from the surface. The haze appears as delicate structure in the brightening sky, and the layers create subtle banding that adds visual interest to the otherwise smooth gradient from dark to light. After several more hours, the brightening reaches the point where the landscape around you becomes dimly visible in the pre-dawn light, and you can see terrain features without relying entirely on starlight or rover lights. The visibility remains low, similar to deep twilight on Earth, but it marks a significant change from the darkness that dominated the previous many hours. The ground shows its colors again, with reddish-brown areas and lighter ice patches becoming distinguishable instead of appearing as uniform gray in the limited light. The stars fade progressively as the sky continues brightening, and the Milky Way becomes less prominent, its light overwhelmed by the increasing sky glow. The brightest stars remain visible, and planets that happen to be above the horizon retain visibility longer than fainter stars. But the rich star field that characterized the night sky gradually diminishes as dawn approaches. The transition demonstrates how even a very thin atmosphere can scatter enough light to affect sky brightness. And it shows that Pluto's atmosphere, while far thinner than Earth's, is not entirely negligible in its effects. The first direct sign of the approaching sun appears when the very tops of distant mountains to the east catch sunlight and begin to glow while the surrounding lowlands remain in shadow. The effect resembles alpenglow on Earth, where high peaks catch sunrise light before valleys, and it creates isolated bright spots on the horizon that mark the sun's imminent appearance. The mountains glow with reflected sunlight for many minutes before the sun itself rises high enough to be seen from your lower elevation. And watching these distant peaks illuminate provides a preview of the sunlight that will soon reach your location. The atmosphere becomes more visible as a definite haze in the eastern sky, and the layers show clearly in the brightening light as blue-tinted bands stacked above the horizon. The haze particles scatter the increasing sunlight and create the blue color through the same physical process that creates blue sky on Earth, though the effect is more subtle here because the atmosphere is so much thinner. The beauty of the illuminated haze layers rivals sunset's display, and the delicate structures catch light in ways that emphasize their layered nature and their role in Pluto's atmospheric chemistry. Finally, after a total night duration of over 76 hours, the sun appears on the eastern horizon as a brilliant point of light that grows quickly in intensity as more of the solar disk rises above the horizon. The sunrise happens over the course of an hour or more because of the slow rotation, and the sun climbs gradually into the sky instead of leaping upward as it seems to on Earth during its much faster sunrise. The light falling on the landscape around you begins as dim illumination that barely changes the appearance of the terrain and strengthens gradually as more of the sun becomes visible and its light reaches more directly toward your position. The temperature begins its slow rise from nighttime minimum toward daytime equilibrium, though the change will take many hours to complete and will amount to only a few degrees overall. The frost on surfaces starts to sublimate in areas where direct sunlight now falls, turning from solid ice directly into gas without melting, and the white coating gradually disappears as the molecules return to the atmosphere. The same frost will form again during the next night, and this cycle of deposition and sublimation continues day after day and year after year, moving volatiles between atmosphere and surface in response to temperature changes driven by Pluto's rotation. With daylight returning, the landscape reveals itself again in full detail, and you can see the terrain features that were hidden or obscured during the long night. The region around your current position shows varied geology with mixed terrain types, and the dawn light creates long shadows that emphasize surface relief and texture. The sun is up, the stars fade into the bright sky, and Charon appears as a full grey disk in its usual position overhead. A new day has begun on Pluto, And the exploration can continue with full visibility of the fascinating surface that covers this distant world. The daylight reveals your current position sits near the boundary between different geological provinces, and the terrain ahead shows characteristics distinct from the regions explored during previous phases of the journey. To the north, relatively smooth plains extend toward Pluto's polar regions, while to the south, rougher terrain rises toward equatorial areas where you traveled before. The rover's location in this intermediate zone offers opportunities to examine transition areas where different geological processes operated at different times and created boundaries between surface types. Driving northward begins the next exploration segment, moving toward regions that experienced different histories than the equatorial zones. The northern plains show fewer impact craters than the ancient highlands, indicating a younger surface age, but they lack the extreme youth of Sputnik Planitia's convecting nitrogen ice. The surface here consists of water ice, with patches of volatile ices, including nitrogen and methane, and the mixture creates varied textures and appearances across the landscape. Some areas appear bright where fresh frost accumulated, while other areas show darker tones where tholins colored the ice through radiation processing. The variation creates a mottled pattern that changes over distances of kilometers, giving the terrain visual interest while maintaining an overall relatively smooth character. The rover travels across this terrain easily, finding routes between obstacles and following areas where the surface is firm and level. Occasional low ridges cross the plain, rising only a few tens of meters above the surrounding terrain, but creating enough relief to be noticeable in the otherwise flat landscape. These ridges may represent ancient fault lines or fractures that broke the ice crust in the distant past. Or they may be pressure ridges where ice experienced compression and buckled upward. The exact formation mechanism remains uncertain without detailed study, but their presence indicates geological activity occurred here at some point in Pluto's history. As the rover continues northward, the latitude increases, and the sun's angle above the horizon decreases slightly, creating a small change in lighting conditions that becomes noticeable after traveling many kilometers. Pluto's rotational axis tilts about 120 degrees relative to its orbital plane, giving the world extreme seasons where each pole experiences extended periods of continuous daylight, followed by extended periods of continuous darkness as Pluto moves around its 248-year orbit. Currently, the Northern Hemisphere is experiencing summer conditions with the sun visible from the North Polar region, but when Pluto reaches the opposite side of its orbit, in about 124 years, the Northern Hemisphere will experience winter darkness. The terrain begins to show more complex patterns as you approach the higher latitudes, and linear features appear on the surface, aligned roughly east-west across the plain. These lineations represent surface structures whose origin remains unclear from visual observation alone, though they likely relate to tectonic forces or thermal contraction that stressed the ice crust and created fractures. The lines extend for many kilometers, crossing the landscape in roughly parallel sets, and their regular spacing suggests an organized process rather than random breakage. Driving across these features reveals they are shallow troughs a few meters deep and several meters wide, noticeable but not obstacles. The journey brings you to an area where the terrain character changes again, and ahead, the surface shows an unusual texture that from a distance appears almost rippled or corrugated. Approaching this area reveals the texture consists of low ridges and troughs oriented in a consistent direction, creating a grain to the landscape that differs from anything encountered previously. The ridges rise only a meter or two above the troughs, making them subtle features, but their regular spacing and alignment create a distinctive appearance. This type of terrain, called bladed terrain where it appears in equatorial regions, also manifests at higher latitudes with somewhat different characteristics. Stopping to examine the ridged terrain up close shows the features consist of water ice, rather than the methane ice that forms the dramatic blades near the equator. The process forming these features involves sublimation erosion similar to the blade formation mechanism, but operating under different temperature and radiation conditions at higher latitudes. The result is more subtle, ridging rather than towering blades, but the underlying physics remains similar, with differential sublimation carving the surface into aligned ridges over long timescales. The features demonstrate that surface shaping processes operate across Pluto's surface at different latitudes, with variations in expression depending on local conditions. Walking between the ridges allows closer inspection of the ice composition and structure, and the water ice here appears clean and relatively pure, without heavy tholin contamination. The lighter color compared to equatorial regions may result from less radiation exposure or from frost deposition that covers older, darker materials. But regardless of cause, the terrain here appears brighter and fresher than the ancient highlands examined earlier. The brightness gives the landscape a cleaner appearance, and the subtle ridging creates visual interest through texture rather than through color variation. Returning to the rover and continuing northward takes you across more ridged terrain that extends for many kilometers before gradually transitioning back to smoother plains. The variation in terrain types over relatively short distances demonstrates Pluto's geological complexity, and the fact that such a small world displays this much diversity suggests that multiple processes operated at different times and locations to create the current surface. Understanding the full history would require detailed study of many regions and correlation of features observed in different locations to build a comprehensive picture of how Pluto evolved. The decision to turn back toward more thoroughly explored regions comes after traveling deep into the northern plains, and the rover begins the return journey southward toward areas where previous exploration established familiar landmarks. The trip back covers the same terrain from a different direction, and the changing perspective reveals features that were less noticeable during the northward journey. The angle of light affects what is visible, and the same landscape can appear quite different when viewed from the opposite direction, especially on a world where shadows are sharp and no atmospheric haze softens the light. The return trip takes many hours, and the sun moves through its slow arc across the sky, changing position noticeably during the long drive. The lighting shifts from the angle that prevailed during the northward journey, and the different illumination creates different shadow patterns that alter the landscape's appearance. What appeared as one texture under morning light shows different characteristics under afternoon illumination, and the changing conditions make the return journey feel less repetitive than simply retracing a familiar route. The landscape continuously reveals new aspects depending on viewing angle and lighting. As the rover approaches the region where sunrise was observed, you recognize features from the earlier observations and confirm your position relative to landmarks established during previous exploration phases. The terrain ahead includes the transition zones explored before night fell, and beyond those areas lie the more dramatic features, including the blade terrain, the dark plains, and the mountains at Sputnik Planetia's edge. The mental map of Pluto's geography builds with each exploration segment, and the various regions begin to connect into a comprehensive understanding of how this world's surface is organized and how different areas relate to each other. The journey continues southward, passing through familiar transition zones and approaching the edges of Cthulhu Macula, where the dark terrain begins. The reddish-brown coloration becomes apparent ahead, and the contrast with the lighter plains you have been crossing marks the boundary clearly. Entering Cthulhu Macula again means returning to the ancient, heavily cratered terrain that characterizes much of Pluto's surface. And the darker colors create a different visual environment than the brighter northern plains. The change demonstrates the variety contained within a world only 2,380 kilometers across. Smaller than Earth's moon, but geologically diverse enough to rival much larger planets. Crossing Cthulhu Macula again takes you over terrain seen before, but the route differs enough that new craters and features appear along the way, showing that even within a single geological province, variation exists from location to location. Some craters show bright rays more prominently than others, and some areas appear darker than average, while others show lighter tones. And the variation within the overall dark region adds complexity to what could otherwise seem monotonous. Each crater has its own size and shape and age, and each contributes to the overall landscape in a unique way. The approach to Sputnik Planitia comes from a different direction than the original landing approach, and the bright ice plain appears on the horizon as a white expanse contrasting with the dark terrain you are currently crossing. The boundary between Cthulhu Macula and Sputnik Planitia marks a dramatic transition from ancient to young, from dark to bright, from inactive to active, and the contrast makes the boundary one of Pluto's most striking features. Driving toward that boundary brings you closer to familiar territory where the original landing site lies, and the journey begins to feel like it is coming full circle after exploring many different regions across Pluto's near hemisphere. The sun continues its slow arc across the sky, and the day progresses towards its midpoint, where the sun will reach its highest elevation before beginning the equally slow descent toward the western horizon, and another sunset many hours in the future. The progression of time on Pluto is measured in such long units that Earth-based instincts for daily rhythms become irrelevant. And adapting to the 6.4-day rotation requires abandoning expectations based on Earth's 24-hour cycle. The day here stretches long enough that many different activities, observations, and explorations can fit into a single daylight period, and the unhurried pace allows thorough examination of regions without time pressure. The rover reaches the edge of Sputnik Planitia from a different angle than the original approach, and the transition from dark cratered highlands to bright nitrogen ice plain demonstrates once again the dramatic contrasts that characterize Pluto's surface. The boundary appears sharp in some areas and gradual in others, depending on local topography and the behavior of nitrogen ice at the interface between plain and highland. Driving onto the plain brings the rover back to smooth cellular terrain, and the familiar polygon patterns appear beneath the wheels as the vehicle moves across the nitrogen ice toward the general area where the landing site is located. The cellular patterns show the same characteristics observed during the initial exploration, with bright cells separated by darker boundary trenches, where material accumulates as the convection currents carry surface ice toward the edges. Each cell represents millions of years of slow circulation, and the surface you drive across is younger than human civilization by thousands of times, constantly renewed by the convection process that erases older features and brings fresh ice to the surface. The geological activity happening here is rare in the outer solar system, where most worlds froze solid billions of years ago and no longer show active surface processes. Navigating across the plane using landmarks proves challenging because the uniform appearance of the nitrogen ice makes one area look much like another, and only the polygon boundaries provide reference features. Instruments guide the rover toward the coordinates where the landing site is located, and eventually the lander appears on the horizon as a small vertical feature against the flat white plain. Approaching the lander feels like returning home after a long journey, even though the site represents only a temporary base on an alien world. And the vehicle provides a familiar landmark that anchors your position on this vast plain. Stopping the rover near the lander completes the surface exploration circuit, and stepping out onto the nitrogen ice brings you back to the location where the first steps on Pluto were taken, what now feels like a long time ago. The ice beneath your boots feels the same as it did during that first walk, solid and cold and smooth, and the plain around you shows no visible change despite the many hours that have passed since the initial landing. The timescales of change on Pluto are so long that human observation periods cannot detect any motion or modification except through precise instruments over extended times. Looking around at the landscape from this familiar position allows reflection on the journey that covered so many different regions and terrain types. From the nitrogen ice plain to the water ice mountains, to the ancient highlands, to the dark organic rich plains, to the bizarre blade terrain, and back to the plain again. Each region showed unique characteristics that revealed different aspects of Pluto's geological history and different processes that shaped the surface over billions of years. The diversity contained within such a small world exceeded what many scientists expected before new horizons revealed Pluto's true nature. The Sun's position shows that considerable time has passed during the exploration, and the day has progressed well past its midpoint toward the afternoon period that will eventually lead to another sunset. The slow solar motion means the transition from day to night will take many more hours, and there is ample time for final observations and preparations before darkness returns. The day-night cycle here is so extended that rushing feels unnecessary, and the pace of activities can remain unhurried because each phase of the day lasts longer than entire days on Earth. Charon remains in its permanent position in the sky, appearing as a full grey disk now that the sun illuminates the moon from the same hemisphere where you stand on Pluto's surface. The moon's features are clearly visible, including the dark polar region called Mordor Macula and the lighter equatorial zones that give Charon a two-toned appearance. The moon's surface shows its own craters and ridges and evidence of geological activity in its past, and viewing it from Pluto's surface provides a perspective on how close the two bodies orbit each other and how their mutual gravitational interaction shaped both worlds. Walking away from the landing site one final time allows a last close examination of the nitrogen ice and its properties, and you move toward the nearest polygon boundary to observe the dark material accumulated in the trench. The boundary trenches contain the oldest surface material available, on Sputnik Planitia, swept there by the spreading ice from cell centers, and the concentrated tholins create the dark lines that trace the cellular patterns across the plane's surface. Kneeling beside a trench to examine the material more closely shows that even this darkest material on the plane is still primarily ice. Just ice that contains a higher concentration of organic molecules than the bright cell centers. Standing again and looking across the plane from this low perspective shows the subtle topography that exists even on this flat surface, with cell centers slightly higher than their edges and gentle undulations visible when you look carefully at the long sight lines. The plane is not perfectly flat, but rather shows the complex three-dimensional structure created by the convection process. And what appears uniform from orbit reveals more detail when observed from ground level. The differences are small, measured in meters rather than kilometers, but they demonstrate that even the smoothest terrain on Pluto has texture and variation when examined closely. The sun continues its slow descent toward the horizon, and the angle of sunlight becomes lower as the afternoon progresses toward evening on this long Plutonian day. Shadows grow longer across the ice, and the contrast between illuminated surfaces and shadowed areas increases as the solar angle decreases. The quality of light changes subtly, becoming more golden and less harsh as it passes through more of Pluto's thin atmosphere at the lower angle, though the atmosphere is so tenuous that the effect is minimal compared to sunset on Earth. Preparations for the approaching night begin with checking equipment and instruments that will continue recording data through the darkness, and the lander's systems are configured to operate through the extended night period that will last more than 3 Earth days. The temperature will drop during darkness. Though the difference between day and night on Pluto is smaller than you might expect, because the world is already so cold that further cooling changes the numbers only slightly. The nitrogen ice remains solid regardless of sunlight, and the surface conditions remain stable through the day-night cycle at Pluto's current position in its orbit. The sky begins to show deeper color as the sun approaches the horizon, transitioning from black with a hint of blue during the day to a slightly different shade as twilight begins. The atmospheric haze layers become more visible in the slanted light, appearing as delicate blue bands stacked above the horizon where the sun is descending. These layers extend high into the atmosphere and represent the photochemical hazes that form when sunlight interacts with methane and nitrogen, creating complex organic molecules that scatter light and create the blue color. Watching the sunset from Pluto's surface is a slow process because the sun moves so gradually across the sky, and what would take minutes on Earth takes hours here. The sun appears as a bright point rather than a disk because of the enormous distance, and it sinks toward the horizon without growing larger or changing shape as it would on a world with a thicker atmosphere. The light dims progressively, and stars that were invisible during the day begin to appear in the darkening sky opposite the sunset, slowly emerging as the background brightness decreases. Charon remains visible throughout the sunset, its position unchanged in the sky because of the tidal locking between the two worlds, and the moon's illumination changes subtly as the geometry shifts. From your position on Pluto's surface, Charon goes through phases just as Earth's moon does. But the phase depends on the Sun's position rather than Charon's orbital position, because Charon doesn't orbit relative to an observer on Pluto's surface. The moon currently appears nearly full, and its grey surface reflects sunlight down onto Pluto's landscape, even as the sun itself disappears below the horizon. The moment of sunset arrives without fanfare, and the sun's bright point touches the horizon and then slowly sinks below it, the last light disappearing and leaving only the atmospheric haze illuminated from below. The haze glows in blues and purples for a time after the sun itself is gone, creating an extended twilight that gradually fades as the light source drops further below the horizon. The temperature sensors show a slight decrease as the direct sunlight ends, but the change is small because solar heating is minimal at this enormous distance even during the day. Darkness settles across Sputnik Planitia, slowly rather than suddenly, and the transition from twilight to full night takes additional hours as the last scattered light fades from the upper atmosphere. The stars become brighter and more numerous as the sky darkens completely, and eventually the heavens display more stars than you have ever seen from any location. The Milky Way appears as a bright band stretching across the black sky, its structure visible in extraordinary detail, with thousands of individual stars resolved within the galactic band. Charon dominates the sky as the brightest object now that the sun has set, and the moon's grey surface shows clear detail even from this distance of 19,000 kilometers. The reddish dark region near Charon's North Pole is visible as a cap covering the upper portion of the disk, and the boundary between dark and light regions creates a distinct line across the moon's face. The moon appears about 8 times larger in angular size than Earth's moon appears from Earth, and surface features are clearly distinguishable without optical aid. Standing in darkness on the nitrogen ice plain, with Charon overhead and the Milky Way stretching across the sky, creates a profound sense of being somewhere far from home, somewhere at the edge of the solar system, where the familiar planets are invisible and the sun is just another bright star. The silence continues unchanged from day to night because sound requires atmosphere, and Pluto's atmosphere is far too thin to transmit any noise. There is no wind, no weather, no sound of any kind, except what you might create through movement or equipment operation. The stars do not twinkle on Pluto because there is almost no atmosphere to distort their light, and each point of light shines steady and constant against the black. Constellations appear the same as they do from Earth, because Pluto's distance, while enormous by human standards, is small compared to the distances to stars, and the stellar patterns remain familiar. Finding Earth among the stars is impossible without knowing exactly where to look, because from this distance, the inner solar system is lost in the sun's glare, and even the sun appears simply as an exceptionally bright star, rather than as the overwhelming presence it is when viewed from the inner planets. The night on Pluto will last approximately 3.2 Earth days, because the rotation period is 6.4 Earth days, and night occupies half of each rotation. This extended darkness means that observations and activities can proceed without any sense of time pressure, and the slow passage of time on Pluto allows a different relationship with the day-night cycle than what humans experience on Earth. There is no urgency to complete tasks before darkness falls, and no need to wait impatiently for sunrise, because each phase extends for so long that adaptation becomes necessary. Moving around the landing site in darkness requires lights from the suit and equipment, because starlight and Charon light, while beautiful, do not provide enough illumination for detailed work or safe movement across uncertain terrain. The lights create small pools of visibility against the overwhelming darkness, and anything beyond the illuminated areas disappears into blackness. The nitrogen ice reflects the light well, and the plain around the landing site shows the same characteristics it displayed during daylight, unchanged by the absence of the sun. The experience of night on Pluto reveals aspects of the environment that were less apparent during the day, and the darkness emphasizes the isolation and the distance from the rest of the solar system. The temperature continues its slow decline as the night progresses, and ice behavior begins to shift as some atmospheric gases freeze out and deposit on the surface. The atmosphere itself becomes slightly thinner during night as nitrogen condenses onto the cold surface, and this process will continue throughout the long dark period until sunrise reverses the trend. Looking up at the unchanging stars and the motionless Charon reinforces the tidal locking that keeps the same hemisphere of Pluto always facing the moon. And from this location, on the near side, Charon will never rise or set, but instead remains in the same position throughout days and nights and years and centuries. An observer on Pluto's far hemisphere would never see Charon at all, and the sky there would contain only stars and the distant sun, without the large grey moon that dominates the view from this side of the planet. The distant sun becomes the focus of attention once full darkness has settled across Pluto and the stars fill the sky in their thousands. And locating the sun among all those points of light requires knowing where to look in the constellations. The sun appears in the same region of sky where Earth's sun would be located, as seen from the outer solar system. But instead of the overwhelming bright disk familiar from Earth, it appears as a single bright point among other stars. The sun is the brightest star in Pluto's sky by a considerable margin, brighter than any other stellar object. But it is still recognizably a star rather than the massive presence that dominates Earth's daytime sky. The brightness difference between the sun as seen from Earth and the sun as seen from Pluto is enormous, and the numbers help convey the scale of the distance involved in reaching this remote location. The sun appears roughly 1,600 times dimmer from Pluto than from Earth, which means that sunlight here provides about the same illumination as Earth receives during deep twilight or under a full moon. During Pluto's day, the landscape receives enough light to see clearly, but the quality is different from the bright sunlight that illuminates Earth. And shadows are less harsh because the light source appears as a point rather than a disk. The distance that separates Pluto from the Sun varies because Pluto's orbit is significantly elliptical. And the planet travels from a closest approach of about 29.7 astronomical units to a farthest distance of 49.3 astronomical units. As it completes its long orbit, 1 astronomical unit equals the average distance between Earth and the Sun, roughly 150 million kilometers. So Pluto's distance ranges from about 4.4 billion kilometers at closest approach to about 7.4 billion kilometers at its farthest point. Currently, Pluto is somewhere in the middle of that range, approximately 5.9 billion kilometers from the Sun. Light takes time to travel even at its tremendous speed of 300,000 kilometers per second. And the light currently arriving at Pluto from the Sun left the solar surface about 5.5 hours ago. This time delay means that if something happened on the Sun right now, observers on Pluto would not see the result for more than 5 hours, and any communication with the inner solar system must account for this significant light travel time. Messages sent from Earth to a spacecraft near Pluto take over 5 hours to arrive, and the response takes another 5 hours to return, creating a communication delay of more than 10 hours round trip. Standing on Pluto's surface and looking at the distant Sun creates a perspective on the scale of the solar system that is difficult to achieve from Earth, where the Sun dominates the sky and fills human awareness. From here, the Sun becomes one object among many, still important as the source of what little light and heat reaches this far, but no longer the overwhelming presence that defines existence. The Sun is part of the sky rather than the focus of it, and the stars receive equal attention because they shine nearly as brightly. The orbital period that Pluto requires to complete one trip around the Sun reflects the enormous distance and the weaker gravitational pull at this range, and the planet takes 248 Earth years to make a single orbit. This extended year means that Pluto moves slowly through the zodiac constellations, as seen from the Sun, and the orbital motion is not perceptible over human timescales. The last time Pluto occupied its current position in its orbit was in the 1700s, long before the planet was discovered and before humans had any idea that worlds existed this far from the Sun. The orbital eccentricity that carries Pluto from 29 to 49 astronomical units has significant consequences for the planet's environment and behavior. And during the closest approach to the Sun, Pluto actually moves inside Neptune's orbit for about 20 years. This happened most recently between 1979 and 1999, when Pluto was temporarily the 8th planet from the Sun instead of the 9th, though the two planets' orbits are tilted relative to each other, so collision is impossible. Pluto will not return to perihelion, its closest approach to the Sun, until the year 2237, more than 2 centuries from now. The closer distance during perihelion brings more solar energy to Pluto's surface and causes changes in atmospheric density and ice distribution, and observations suggest that Pluto's atmosphere expands during the warmer periods and contracts again as the planet recedes toward aphelion. The seasonal cycle on Pluto is nothing like seasons on Earth, and instead represents long-term changes that occur over decades and centuries as the planet slowly orbits and the distance from the Sun changes. Understanding these cycles requires observations spanning many human generations because the timescales are so extended. Looking at the Sun from Pluto and thinking about Earth creates a strange sense of connection and distance at the same time, because Earth is somewhere near that bright point, but completely invisible from here. Every human who has ever lived was born on that invisible world orbiting close to that distant star, and all human history occurred within a tiny region of space near that bright point. From Pluto's perspective, all the inner solar system is compressed into the area around the Sun, and the separation between Mercury, Venus, Earth, and Mars becomes meaningless because they all occupy essentially the same location. The outer planets are somewhat more distinguishable from this vantage point because they orbit farther from the Sun and can appear separated from the solar glare, though finding them requires knowing their current positions and looking carefully at the right areas of sky. Neptune is the nearest major planet to Pluto, orbiting at about 30 astronomical units compared to Pluto's current 40. And from here, Neptune would appear as a faint blue star if you could locate it. Uranus, Saturn, and Jupiter orbit farther inward at 19, 9.5, and 5 astronomical units respectively, and they appear progressively closer to the Sun from Pluto's perspective. The Kuiper Belt, the region of space where Pluto orbits, extends from about 30 astronomical units to approximately 50 astronomical units from the Sun, and contains thousands of objects ranging from small icy bodies to dwarf planets, comparable in size to Pluto. This region represents the outer edge of the solar system's planetary zone, and beyond it lies the scattered disk, where objects have more extreme and tilted orbits. Pluto is one of the largest known members of the Kuiper Belt, though not the largest, and it shares this region with other substantial worlds. The largest known Kuiper Belt objects after Pluto include Eris, which is slightly smaller in diameter than Pluto, but more massive, and Makemake and Haumea, both smaller than Pluto, but still substantial worlds in their own right. Eris orbits much farther out, currently near 96 astronomical units from the Sun, in its highly elliptical orbit, and its discovery in 2005 prompted the redefinition of planet that led to Pluto's reclassification as a dwarf planet. These distant worlds remain largely mysterious because only Pluto has been visited by a spacecraft, and the others are known primarily through telescopic observations. The Pluto-Charon system stands out among Kuiper Belt objects as the largest known binary pair, and the relationship between the two bodies is unique in the solar system because their masses are similar enough that both worlds orbit a point in space between them, rather than having one clearly orbit the other. Most moon systems involve a large planet and much smaller satellites, but Pluto and Charon function more as a double planet, locked in their mutual orbit, with each world always showing the same face to the other. Beyond even the Kuiper Belt and the scattered disk lies the Oort cloud, a theoretical sphere of icy objects that extends from about 2,000 astronomical units to as far as 100,000 astronomical units from the Sun, reaching nearly halfway to the nearest star. This region has never been observed directly because the objects are too small and too far to detect with current technology. But comets originating from the Oort cloud regularly fall into the inner solar system and confirm that a vast reservoir of icy material exists in the outer reaches. The Voyager spacecraft, which have traveled farther from Earth than any other human-made objects, are currently in the region between the Kuiper Belt and the Oort cloud, still communicating but incredibly distant. Thinking about these scales while standing on Pluto creates a layered understanding of distance, where Pluto is simultaneously incredibly far from Earth, and yet still firmly within the Sun's realm of influence, nowhere near the true edge of the solar system. The Sun's gravity extends to the Oort cloud and perhaps beyond, and Pluto orbits well within that gravitational sphere. The distance from Pluto to the Sun is enormous by human standards, but it is small compared to the gap between the Sun and the nearest other stars. The nearest star to the Sun is Proxima Centauri, which orbits as part of the Alpha Centauri triple star system at a distance of about 4.2 light-years. And light from that star takes 4.2 years to reach the solar system. Converting that to astronomical units yields about 270,000 AU, which means Proxima Centauri is roughly 5,000 times farther from the Sun than Pluto is. The gulf between stars dwarfs the distances within solar systems, and interstellar space represents a vastly larger scale than the already enormous distances between planets. Looking at the stars from Pluto's surface and understanding these distances creates a framework for comprehending the universe's structure. Where planets orbit stars at distances measured in astronomical units or billions of kilometers, stars are separated by light years or trillions of kilometers, and galaxies contain billions of stars separated from other galaxies by millions of light years. Each level of scale represents a jump of many orders of magnitude, and human intuition struggles with the numbers because they exceed everyday experience so dramatically. The time spent on Pluto's surface has stretched across a significant portion of one long Plutonian day, and the journey through different regions has covered hundreds of kilometers of varied terrain, from the smooth nitrogen ice plains to the water ice mountains, to the ancient cratered highlands, to the dark, organic-rich deposits, to the bizarre blade terrain, and back again. Each region revealed different aspects of this small world's character and demonstrated that geological diversity is not limited to large planets, but can appear on bodies of any size given the right conditions and history. Preparations for departure begin during the extended night, and the equipment is checked and configured for the ascent from Pluto's surface back to orbit, where the return vehicle waits. The lander systems have performed well throughout the exploration period, and the stored samples and data represent a comprehensive survey of Pluto's surface conditions and composition. Everything that can be observed and measured from surface level has been recorded, and the next phase of the mission involves returning that information to the wider scientific community. The low gravity that made walking and driving easy on Pluto's surface also makes departure less demanding than it would be from a larger world. And the lander requires relatively little energy to break free from the planet's gravitational pull. The escape velocity from Pluto is about 1.2 kilometers per second, far lower than Earth's 11.2 kilometers per second. And reaching orbit requires a gentle acceleration compared to the powerful launches necessary to leave Earth. The ascent can be slow and controlled rather than the rapid, violent departure that Earth launches demand. The final hours before liftoff include last observations of the sky and the landscape, and you spend time looking at Charon's position overhead and the Milky Way stretching across the darkness and the nitrogen ice plain extending to the horizon in all directions. This place has become familiar through extended exploration, and the features that seemed alien at first now feel like known terrain, mapped and traversed and understood, at least in the limited way that brief visits can provide understanding. The stars continue their slow motion across the sky as Pluto rotates, and the constellations shift position gradually during the hours of observation, though the changes are subtle because the rotation period is so long. Charon remains fixed in its position because of the tidal locking, and the moon serves as a stable reference point that doesn't move even as the stars wheel slowly around it. The sun remains below the horizon because night continues for days, and sunrise is still far in the future when the liftoff finally occurs. The moment of departure arrives without drama, and the lander's engines fire gently to lift the vehicle from the nitrogen ice surface, where it has rested throughout the exploration period. The acceleration is mild because the gravity is weak, and the ascent feels more like floating upward than climbing against a gravitational pull. The surface drops away below slowly, and the familiar landing site becomes smaller as altitude increases. The disturbed ice around the lander legs, visible as a mark of human presence on this otherwise untouched plane. Rising through Pluto's thin atmosphere happens quickly because the atmosphere extends only about 1,600 kilometers above the surface, but contains very little mass at any altitude, and the transition from flying through atmosphere to moving through vacuum is gradual rather than distinct. The haze layers pass by as altitude increases, and the blue atmospheric bands that were visible from the surface now appear as thin shells around the planet when viewed from above. The sky changes from black with stars to black with planet as you rise, and the horizon curves more sharply, and more of Pluto becomes visible below. Reaching orbital altitude and circularizing the orbit takes additional time and several engine burns, but eventually the lander settles into a stable path around Pluto at an altitude that provides clear views of the entire planet. From this vantage point, the regions explored on the surface appear as parts of the larger whole, and the heart-shaped Tombaugh Regio dominates the visible hemisphere with its bright western lobe of nitrogen ice plains and its darker eastern sections. The water ice mountains appear as bright patches at the edges of Sputnik Planitia, and the dark regions of Cthulhu Macula and other heavily cratered terrain show the reddish-brown coloration that indicates ancient surfaces. Charon appears from orbit as a separate world rather than an object in the sky, and the moon's substantial size becomes more apparent when both bodies are visible together as a system. The distance between Pluto and Charon is only 19,600 kilometers, small enough that the two worlds appear close together from any external viewpoint and clearly function as a binary system rather than a planet with a satellite. The moon's grey surface contrasts with Pluto's varied colors, and the dark polar cap on Charon stands out clearly against the lighter equatorial regions. The orbit carries the viewpoint around Pluto's globe, and regions that were not visible during the surface exploration come into view, including the far hemisphere that never sees Charon, and the polar zones that experience the most extreme seasonal variations as Pluto's tilted axis and elliptical orbit combine to create long periods, continuous sunlight alternating with equally long periods of darkness. The South Polar region currently experiences winter night, and the area lies in darkness that will continue for many Earth years until Pluto's slow orbit brings the sun back to that part of the planet. The variety visible from orbit confirms what the surface exploration suggested, that Pluto contains many different terrain types and surface processes compressed into a relatively small world. And the geological activity that created the smooth plains and the water ice mountains and the atmospheric haze demonstrates that small size does not necessarily mean geological death. Many processes that operate on larger planets also function here, though sometimes in different ways or at different scales, and Pluto's complexity rivals that of much larger bodies. Observing Pluto from orbit allows reflection on what New Horizons spacecraft revealed when it flew past this system in July 2015. And the transformation of Pluto from a fuzzy dot at the limit of telescopic resolution to a detailed world with mapped regions and understood geology represents one of the great achievements of planetary exploration. Before New Horizons, Pluto was barely known, and even basic properties like its exact size were uncertain. The flyby changed everything and revealed a world no one had predicted, with active geology and complex terrain and a surprisingly substantial atmosphere. The data that New Horizons returned during and after its brief flyby took many months to transmit, because the enormous distance between Pluto and Earth limited communication rates to very low speeds, and the complete dataset was not received until more than a year after the encounter. Every image and measurement had to travel more than 5 billion kilometers at the speed of light, taking over 5 hours to make the journey. And the spacecraft's small antenna and limited power meant that data trickled back slowly over the long, light travel distance. Future missions to Pluto remain in the planning and proposal stages, and no spacecraft is currently scheduled to return to this system, though interest in further exploration continues in the scientific community. An orbiter mission would allow extended study of Pluto and Charon and could observe seasonal changes and atmospheric behavior over longer periods than a flyby permits. Landing missions, while more complex, would provide the kind of detailed surface access that brief visits from orbit cannot match and would allow direct sampling of different terrain types. The experience of being on Pluto's surface, even as a thought experiment or future possibility, emphasizes that this is a real place with specific characteristics and features, not just an abstract concept or a point of light in the sky. The nitrogen ice is real, the water ice mountains are real, the tholins darkening ancient surfaces are real, and the processes that shape this world operate according to physical laws that can be understood and measured. Pluto exists as a physical location in space that could potentially be visited and explored in detail. Looking at Pluto from orbit one final time before beginning the long journey back toward the inner solar system, the heart shape of Tombaugh Regio remains the most recognizable feature. And the contrast between the bright ice plains and the darker surrounding terrain creates the distinctive pattern that made Pluto instantly memorable when the first high-resolution images arrived from New Horizons. The heart was not named for romantic associations, but for Clyde Tombaugh, who discovered Pluto in 1930 from Lowell Observatory in Arizona. And the feature stands as a fitting tribute to the astronomer who first found this distant world. Charon orbits nearby in its eternal locked dance with Pluto, the two bodies forever showing the same faces to each other as they circle their common center of mass every 6.4 days. And the system continues its slow orbit around the distant sun that will take more than 2 centuries to complete. The worlds will be here long after any visitors depart, continuing their ancient patterns in the outer darkness, shaped by processes that operate on geological timescales far longer than human ones. The Kuiper Belt contains thousands of objects, and Pluto represents just one example of the small icy worlds that populate this region of the solar system, each with its own characteristics and history and surface features waiting to be discovered. The outer solar system holds as much diversity as the inner system. though the processes and materials differ because of the cold and the distance from the sun. And exploration of this region has only just begun. The journey to Pluto covered billions of kilometers and required years of travel time for the New Horizons spacecraft. And any future mission will face similar constraints because the distance cannot be shortened, and the laws of orbital mechanics limit how fast spacecraft can travel. The outer solar system is genuinely far from Earth, and reaching these distant worlds requires patience and long-term planning and acceptance that exploration happens slowly over the course of years or decades rather than weeks or months. The value of exploring Pluto and the other Kuiper Belt objects lies in understanding how the solar system formed and what conditions exist in the outer regions, and how small bodies retain or lose their internal heat, and what chemical processes operate in environments far from the sun's warmth. Each world visited adds to the overall picture of planetary science and provides context for understanding not just the solar system, but also planetary systems around other stars, where similar processes might create similar worlds. As the orbital path carries the viewpoint away from Pluto and toward departure trajectory, the planet begins to shrink in apparent size, and the features that were distinct from low orbit become less clear as distance increases. The heart shape remains visible for a long time, and the bright plains continue to stand out against darker terrain. But eventually, the details fade, and Pluto returns to being a small, pale disk against the black of space. Charon separates from Pluto visually as the viewing distance increases, and the two worlds appear as distinct objects again, rather than as one system, though they remain close together and clearly connected by their orbital relationship. The pair recedes together into the darkness of the outer solar system, becoming fainter as the light travel time increases and the distance grows toward millions and eventually billions of kilometers again. The sun grows slightly brighter as the return journey progresses inward toward the inner solar system, though the change is gradual and barely perceptible at first because the distances involved are so vast. The stars remain as clear and steady as they were at Pluto, because the thin atmosphere that will eventually surround the spacecraft upon return to Earth is still far away, and the view of space remains unobstructed and sharp. Pluto continues its orbit, undisturbed by the brief visit, and the world that has existed for billions of years, and will exist for billions more, carries on with its slow circulation of nitrogen ice, and its gradual erosion of methane blades, and its seasonal exchanges between atmosphere and surface. The planet is patient in the way that planets are, operating on timescales that make human lifespans vanishingly brief. And what was observed during the visit represents only a single moment in a history that stretches back to the solar system's formation. The memory of standing on that nitrogen ice plain, with Charon overhead and the Milky Way stretching across the black sky, remains clear even as the physical distance increases. And the experience of being somewhere so far from Earth and so different from familiar environments creates a perspective that stays with anyone who makes the journey. Pluto is no longer abstract after being visited, and the specific qualities of that world become part of understanding what exists in the universe beyond the small portion that humans directly experience in their daily lives on Earth.